All right, here we are with the last 2 pages of the 9-1 notes. A lot of things are going to be filled out just to try to speed up these videos for you guys. So everything that we've done is we've been writing these null and alternative hypothesis and then calculating out or be given a p-value or calculate out a p-value and use that to, in essence, make a decision on whether or not to reject the null hypothesis. So the question becomes, are we making the actual right decision? So what can actually happen is you could actually be making a mistake. And these mistakes are called type 1. Oops, I always knew I would do that. But they are called type 1 and type 2 errors. So let me explain how those work. What's really nice is this box really helps define what decision you're making and the actual truth. So down here is our conclusion based on our sample. So we collect that sample, we get our p-value, and we are either going to reject the null hypothesis or fail to reject the null hypothesis. The question is, what is actually the truth? Well, if we reject the null hypothesis and the null hypothesis was false, we made the correct decision. Likewise, if we failed to reject the null hypothesis, meaning we felt that the alternative in essence was true, we made the correct decision. However, what can happen is we can reject a null hypothesis when in fact that null hypothesis was true. This is called a type 1 error. The type 2 error is where we fail to reject the null hypothesis when in fact, the null hypothesis was actually false. So you can see they're defined right here. There's type 1 error and type 2 error. So how in the world do we put this in context? How does this, work? Or how do we interpret the type 1 and type 2 errors? Because that's the most important thing that you'll need to know how to do with these problems. So up on the top here, I have a null and alternative hypothesis that I'm just gonna kind of take you through describing the type 1 and type 2 error here. So the null hypothesis is the assumption that the average Hopkins high school student gets an average of 7 hours of sleep a night. Now, you guys probably don't think that's probably true. So your alternative would say the average high school student gets less than 7 hours of sleep a night. So if we think about this symbolically, it would be like saying the mean is 7. We believe that the mean is less than, is less than 7 hours. Okay? So the type 1 error is basically, we would be saying this. So I'm going to kind of write it here. Type 1 error would be saying, okay, we would actually say students, or HHS students, get less than 7 hours of sleep. And it's really, I should say, saying should be in here at the beginning. So saying HHS students get less than 7 hours of sleep when, in fact, they do get 7 hours of sleep. Okay. All right, so then the type 2 error is, in essence, kind of doing the opposite mistake. So the type 2 error is saying students get 7 hours of sleep when in fact they get less than 7 hours of sleep. Okay. So Just to give you a little more practice on this, we have an example down here that deals with the manager of a fast food restaurant. So I'm going to give you a second just to kind of read it for a second. So the long of the short of this is our null hypothesis is the proportion is 0.63. So the proportion is the true proportion of drive-through customers who have to wait more than 2 minutes after their order is placed. So we believe that that proportion is 0.63. The manager is hoping to basically collect a random sample and see if he could actually reduce this by adding an additional employee. Hence why the alternative is less than 0.63. So what you're asked to do is describe the type 1 and type 2 error in this setting, and then explain what is the actual consequence of each. So it's important sometimes to, I know I didn't do it in the above one, but to describe what mistakes, or I'm sorry, the consequences of making these errors actually is in each setting. So in this particular problem here, if I scroll, the type 1 error is if the manager decides that the true proportion of drive-through customers who actually had to wait more than 2 minutes had actually been reduced by adding that additional worker, but in fact, it didn't reduce the proportion. The big consequence of this is that the manager hired an extra worker when she really didn't have to, and this, in essence, cost the company more money because they're paying someone an hourly wage and it's not actually remedying the situation. Take a second to pause if you need to write this down. So now, if you turn the video back on, if you go to the type 2 error, the type 2 error is that the manager actually decided that the true proportion of customers who actually had to wait those 2 minutes wasn't reduced by adding the additional worker, when in fact, adding that worker made a difference. It actually reduced it. So the consequence here is the manager is not going to hire that employee when in fact they should have, which would have provided faster service. So they could have provided that faster service, and here they're not going to, and this is still going to cause the customers to wait longer. They're not going to be happy and potentially not returning. Think about all the times you've had to sit in fast food restaurant lines, drive-through lines, waiting for your food for a long time. After a while, if it happens a lot, I don't know about you, but sometimes I won't even return. All right, if you, for the next problem here, I'm actually going to just do one more practice problem with you. So go ahead, and if you have a copy of the packet and want to do this in the learning targets, if you don't have the learning targets there for some reason in the packet because you don't have a packet, I understand. Just go ahead and write this down on a sheet of paper or just follow along so that you kind of get a good understanding of the null and alternative hypothesis. So in this example, and this is what a typical business would kind of look at. So say if I'm Frito-Lay and I'm making potato chips. So one of the things that I'm going to test is making sure that potato chips have the right salt content on it. So the null hypothesis is the chips contain the correct amount of salt. The alternative will say, well, no, it has the incorrect amount of salt. So this one, if I kind of think about it, is it's going to be a mean's going to equal some number, and this will be a not equal to, because if it doesn't have enough enough salt, the chips won't have a good flavor. If it has too much salt, it's going to be, unedible. It'll almost cause you to gag. So let's think about the type 1 and type 2 error in this particular case. So the type 1 error, okay, is basically we're rejecting the null hypothesis. Okay? So we're actually saying the chips do not have the correct salt content on them, when in fact they actually do. So we rejected the null hypothesis, when in fact everything was A-OK. So in this particular case, the mistake or the consequence we're making is we're destroying a good batch of chips. Okay? Frito-Lay, doesn't necessarily want to throw out bad chips. That's definitely going to cost them some money. Okay? However, if we take a look at the type 2 error, okay, this is saying that the chips are actually good when in fact they're bad. So this is what happens when you buy a bag of chips and you get too much salt on them, or not enough salt, or not enough flavor on them. Something's wrong with them. This is the type 2 error. What's the consequence of this? Well, people are not going to be very happy. Okay? They've just sold a bad batch of chips to everybody, and they're going to probably potentially have to do a recall if it's that bad. Okay? Not only did it cost them time to make the chips, but now they are going to have to recall it. It's going to cost them even more money. It's going to hurt their name brand, and sometimes for some companies, if the mistake is so bad, it can actually put them out of business. So a lot of times when companies will look at these type 1 and type 2 errors, they'll actually decide which one is, more, or which one can they live with more often. So this is what leads to our last page in the notes. So I'm going to flip back to this page, and that's the probabilities of a type 1 and type 2 errors. Now, when calculating out the probability in a type 1 and type 2 error, okay, the probability of a type 1 error is really easy to calculate out because it's actually given to you. Okay? It's whatever alpha is. It's that significance level. Okay? Because what we know is whatever that line in the sand here, alpha is, if our p-value lands here, or our sample lands here, this area here, we're going to reject the null hypothesis. In this area, we're going to fail to reject it. So we're going to fail to reject the null. So this alpha, many times, will be 0.05 if it's not given to you. But if it is given to you, it is that particular value because you're going to be in this area this percentage of the time. So type 1 error is very, very easy to calculate out. Now, the next term up here is called the power. The power of the test, okay, is, as it says here, against a specific alternative is the probability that you're going to reject the null hypothesis at a specific significance level, okay, when the alternative value or parameter is actually true. I like to think of the power as a conditional probability. It's the probability that you reject the null hypothesis given that either your sample mean or your sample proportion is true. Basically, the alternative or the sample that you're using to determine whether or not you're rejecting or not rejecting is true. Now, the importance of this power, okay, is that it helps you calculate out the probability of a type 2 error. So the probability of a type 2 error is simply 1 minus the power. Now, the nice thing is on the AP exam, they never have you actually calculate out this power directly in a problem. What they'll do is they'll actually give it to you if they're asking you to calculate out the probability of a type 2 error. They'll say the power is 0.68. So therefore, if it's 0.68, 1 minus 0.68 is 0.32. That would be the probability of the type 1 error. But to help you see it visually speaking wise, and I think this is important to see, and that's why you have these two diagrams here. So just to explain how this works, the top normal curve is assuming the null hypothesis is true. So if the null hypothesis is true, what happens is we have this level of significance right here, This is the line that divides us whether we reject the null hypothesis or fail to reject the null hypothesis. Okay? So now if we think about this, if the null hypothesis is actually true, okay, and we fail to reject it, we made the correct decision. However, if we rejected it and it was actually true, this is the type 1 error, and hence this is this probability. So this line right here can be arbitrarily moved left and right, so you can adjust it by alpha. So if you want it smaller, you're moving in this direction. If you want it bigger, you're moving in this direction. But now, how does the type 2 error come into play? So the thing is, we have to have the alternative. So here's this either p hat right here, or you could say x bar. So this value becomes our alternative, and we assume that that is the actual true, in this case, proportion. So what happens is we now, okay, get ourselves a normal curve here, okay? And then based off that, actually it'd be not based off this value, but it would be based off of what we think the alternative should be. So now, what happens is if we assume the alternative is true, and we reject the null hypothesis, we are actually making the correct decision. This is actually what we call the power, okay? Basically, as you say, you reject the null hypothesis given the alternative is true. Okay? The type 2 error right here is when you fail to reject the null hypothesis, okay, when the alternative is actually true. So what you can see here is as the power, okay, gets bigger, your type 2 error gets smaller. But at the same time, as your power gets bigger, see how this line is connected? Your type 1 error gets bigger. So your type 1 and type 2 error are tied together by this significance level. So a lot of times companies will look at this significance level and determine which mistake can they live with more. Okay? Can they live with the type 1 error, or can they live with the type 2 error more from a business aspect? Okay? And so they'll make that one a lot bigger and make the other one a lot smaller. Okay? So as I just mentioned there, notice that if you just decrease the probability of a type 1 error, you increase the probability of a type 2 error. Again, you're not expected to calculate out the power. However, you need to know what the power is and how it relates to these values. All right, that ends our video.